this video, I'm going to talk about quadratics. Quadratics can be written in three different forms. One form is the standard form, and the standard form is y is equal to ax squared plus bx plus c. Another form is the vertex form, and the vertex form is y is equal to a times x minus h squared plus k. And the last form is factored form, and factored form is you might have some coefficient times x plus p, x plus q, where p and q are some constants, positive or negative. This shows me my x-intercepts. Which reminds me that I want to talk about what important points do I see from these three different forms. And the important point that I see from standard form, if I plug in x is equal to 0, my two first terms go away and I'm left with just c. Well, when x is 0, I know I'm finding my y-intercept. So what I can immediately see from this first form is my y-intercept. And my y-intercept is always going to be 0, comma, c, whatever c is, whatever that constant is. The important point for my vertex, obviously, is the vertex. And that point is going to be h, comma, k. Whatever I'm subtracting inside of the parentheses is my x value in my vertex, and whatever I'm adding outside is my y value in my vertex. And then the last form, the factored form, shows me my x-intercepts, and those are the numbers that are being subtracted inside of parentheses. So I would have negative p, comma 0, and negative q, comma 0. I should actually have written this as, let me rewrite this. I'm going to rewrite this as x minus p and x minus q. So then I would see my x-intercepts would be p, comma 0 and q, comma 0. The constant that I'm subtracting in the factored form is my x-intercept. All right, for this here, this is my vertex form. And if I can't remember that h, comma k is my vertex, if I can't remember that, I can also use the transformations that I know that are the same as absolute value functions to find what my vertex is. So this h, whatever I'm subtracting from the input before squaring, this tells me how I'm moving horizontally. So if I'm moving right or left. This tells me k, or whatever I'm adding outside of the parentheses, tells me how I'm moving up and down. And I could use those two things to find my vertex if I couldn't remember that h, comma k was my vertex. All right, for this first example here, I have y is equal to 3x squared minus 2. You could say that's standard form, or you could actually really easily convert it into vertex form. And vertex form is the one that you want if you can have it, because it's the easiest one to graph. It tells you the most important information. The most important information on a parabola is the vertex, that point where everything changes direction. So I'm going to convert this into vertex form by what I'm actually subtracting from 0 here. Sorry, what I'm actually subtracting from x there before squaring it is 0. So I could rewrite this as 3 times x minus 0 squared minus 2. This is vertex form now. I didn't change anything. This is the same exact equation as before, but now I can very obviously see what my h is. My h is 0, and my k is negative 2. So I know that the vertex is going to be 0, comma, negative 2. I'm going to plot that. This is my vertex. I know through the vertex, there is a vertical line of symmetry. Both sides of the parabola are going to be the same on both sides of, on opposite sides of the vertex. It's going to look symmetrical. It's going to be the same. So I only need one more point on whatever side I want, just one more point on maybe the right-hand side, and I can use that point reflected over that line of symmetry to find the point on the one point on the other side. So I want to pick an x value that's close to my vertex, and an x value that's close to my vertex is 1. So I'm going to plug in x is 1. And when I plug in x is 1 into my equation, I have y is equal to 3 times 1 squared minus 2, and that's equal to 3 minus 2, which is 1. So I know when x is 1, y is 1. So I have this point 1, comma 1. Now, if I reflect that point, I know this point is 1 away on the right-hand side from the line of symmetry, so I can plot another point 1 on the left-hand side, 1 away on the left-hand side. When I connect with a curved line, since I have a parabola here, and I can see that both sides of that line of symmetry are symmetrical. My vertex, I'm just going to rewrite it, is 0, -2. The axis of symmetry, or the line of symmetry, is x is equal to 0. It's that line that goes through the vertex. That 0 comes from the x value in my vertex. And then the y-intercept is going to be also 0, -2. My vertex falls on the y-intercept. Oh, sorry, on the y-axis. All right, for the next example, I have standard form was given to me. So the easiest way for me to find the vertex is to use that formula, x is equal to negative b over 2a. So all I have to do is identify what's my a, what's my b. A is equal to -1, b is equal to 2. I'm going to plug those things into this formula. So I have -2 over 2 times -1. And that's going to give me, when I simplify, just 1. It'll be -2 over -2, which is 1. So I know my x value in my vertex is 1. And then I just need to find what's my y value. So I'm going to plug x is equal to 1 into my equation here to find what my y value in my vertex is. I do y is equal to -1 squared plus 2 times 1 plus 2. So I just plugged in the 1 wherever I saw an x. And I get y is equal to -1 plus 2 plus 2, which is 3. So I know my y value in my vertex is 3. And that would make my new vertex. So the vertex is 1, 3. And I'm going to plot that 1, 3 right here. And then I'm going to use my line of symmetry. Just draw that. And I'm going to make a mini table to find just one other point, and then I'm going to reflect that over the line of symmetry. So an x value that'd be good to pick would be 0. So I'm going to plug in 0. And when I plug in 0, I know right away I'm going to have 2 is my y-intercept. So when I plug in 0, these two terms are going to go away. I'm going to be left with just 2. So I have 0, 2. And I can reflect that point over the line of symmetry to find 2, 2 is also a point on this graph. And then I connect these in a curved shape. And that's my parabola. The vertex is 1, 3. The axis of symmetry is x is equal to 1. And the y-intercept is 0, 2. In the quadratics unit, we also learned about complex numbers. It was defined that I squared would be equal to -1. And then I could actually use I to represent the square root of -1. And that would help me turn things that I would normally say are no solution into imaginary numbers. So wherever I saw the square root of a negative number, I could turn it into terms of I, that variable I used. We can add, subtract, multiply, and divide these complex numbers. So let's start by multiplying. If I wanted to multiply these numbers, it's exactly like I would multiply if I had x instead of I. I'm just multiplying everything in the left parentheses by everything in the right parentheses. So I'm starting with 2 times 3, which gives me 6. Then 2 times 2i, which gives me 4i. Then I would do -i times 3, which would give me -3i. And then -i times 2i, which would be -2i squared. And then I just simplify. So when I collect my like terms, I'm going to have 6 plus I, and then minus 2i squared. If I ever see I squared, I need to change it. If I can change an imaginary number into a real number, I want to do that. So when I see I squared, I know that's -1. So this I squared here, I'm going to change to -1. So I'm going to rewrite this as 6 plus I minus 2 times -1. That's 6 plus I minus, plus 2, which gives me 8 plus I. So the answer to this one is 8 plus I. For this problem here, I am dividing two imaginary numbers. I can't have I in the denominator, so I have to get rid of I in the denominator somehow. If I was by itself, I could just multiply by I to make it I squared, which I know is -1, which is a real number. But in this case, I can't just multiply by I, because if I do that, I'm going to have 3I plus I squared, and the 3I is going to give me an issue. So what I actually have to multiply is by the conjugate of the base to get rid of that I in the bottom. So I would multiply by 3 minus I, because the rules of the difference of two squares, if I multiply two things, two expressions that have the same first and second term but opposite signs, I know that that middle term, which would normally be my x term, x to the first power term, is going to cancel out. So I multiply by 3 minus I in the bottom. If I do that on the bottom, I have to keep this fraction balanced by multiplying the top by that as well. And then this is how I'm going to simplify this. So I'm going to start by doing the top. I like to separate this, so I start by doing the top, and I do 2 minus I times 3 minus I. And I do this through, so I have 2 times 3, which is 6, 2 times negative I, which is -2I. I have negative I times 3, which is -3I, and negative I times negative I, which is plus I squared. I know that this is going to be 6 minus 5I, and this is going to change to -1, so I'm going to have plus -1. And then when I collect my constants together, I'll have 5 minus 5I. This is going to be the top of my answer. Then I'm going to do the bottom. So the bottom, I know, is 3 plus I times 3 minus I. And this is going to give me the difference of two squares. I'm going to have 3 squared minus I squared. And I know I squared is -1, so I'm subtracting -1 here. And 3 squared is 9. I'll have 9 minus -1, which is 10. So 10 will be in the bottom of my answer. Then I can write my answer as I will have 5 minus 5I over 10. I have to simplify this if I can, and I can take out a 5 in the top. So I can rewrite this as 5 in the top and the bottom. So I can rewrite this as 5 times 1 minus I all over 5 times 2. And then I can simplify this to get rid of my 5's. And I'm left with 1 minus I over 2. And this is my final simplified answer. And I don't have I in the bottom there. We also learned how to solve quadratic equations. So if I was given an equation that looked like this, what I would want to do is I would want to get my all my terms to one side and 0 on the other side. So I want to start by subtracting by 8 on both sides to get this to be x squared minus 5x minus 8 is equal to 0, so I can see if I could factor it to solve. Or I always need it in that form to use like whatever method I want to use to solve these. I'm looking for two numbers that multiply to -8 and add up to -5. And there are no two numbers that I can think of that do that. So that fit here. So I'm going to use the quadratic formula. So I'm going to do x is equal to the square root. Oh, no. What am I doing? X is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And I'm going to plug in all my information that I have. So I know A is equal to 1, B is equal to -5, and C is equal to -8. So I'm just going to plug those things in. I have B is -5, -5. A is 1, so I plug in here and here, and C is -8. And then I see I have -5 is 5 plus or minus the square root of 25 minus 4 times -8, which is plus 32 all over 2. From here, I'm going to get x is equal to 5 plus or minus the square root of 25 plus 32 is 57 all over 2. I can't simplify 57 anymore. I can't simplify that, so I leave it alone, and this is my answer, or these are my answers, because there's two answers there, because I have plus or minus. For the second one here, I still want it in the same form with everything on one side. First thing I'm gonna have to do here is I'm gonna have to distribute that x. So I have x squared minus 3x is equal to 4. And then I want to take that 4 and put it on the left-hand side with my other terms. So I have x squared minus 3x minus 4 is equal to 0. I want to always start by trying to factor. I need two numbers that multiply to -4 and add up to -3. And those are -4 and 1. So I can break this down into x minus 4 times x plus 1. And that's equal to 0, I know. And now I know that one of these two things has to be equal to 0 for this product to be 0. So I have x minus 4 is equal to 0, or x plus 1 is equal to 0, and then I solve these. So plus 4 on both sides here, minus 1 on both sides here, and I get x is equal to 4, or x is equal to -1, and these are my answers. You usually have two answers for a quadratic equation. Sometimes you'll see quadratic word problems, and you'll be given some equation and you'll be asked to find the maximum or minimum usually. And you also might be asked to find something like when the ball hits the ground. This is a problem about a football being thrown. So first thing I'm going to start with is finding the max height. If I'm looking for the max height, that means I'm looking for my vertex. My vertex will always be my maximum or my minimum. So I'm looking for the vertex. This was the equation given to me that models the way the ball is moving. So I know that the easiest way, or what I usually use to find the vertex for these problems, is that formula x is equal to -b over 2a. That's going to tell me the x in my maximum, in my vertex. So I know b is equal to 48. So I have -48 all over 2 times a is -16. And then I'm going to have -48 over -32, which I know is 3 over 2. I'm going to say decimal form, that's 1.5. So I have x is equal to 1.5 in my vertex. Then I need to find the y value because I need to know the height. And when I find x, and sorry, in this case, I'm actually finding t because t is the variable I have in my equation that was given to me, and t represents time, and then h represents height. So t is my input and height is my output. So I need to find what my output is when my input is 1.5. So I'm going to input t, or being 1.5, into this equation. So I have h is equal to -16 times 1.5 squared plus 48 times 1.5. And when I do this, I have to do this in my calculator. 1.5 squared, 1.5 squared is 2.25. So I have 2.25 times -16 plus 48 times 1.5, which gives me 72. Make sure you're doing your exponent first. Don't forget to do that. I saw a lot of mistakes on your test where you did not do that exponent first. So make sure you're doing exponents first, PEMDAS. I have 2.25 times -16 is -36 plus 72 gives me, my height is going to be 36. So the max height is 36. To find when the ball hits the ground, I know I'm looking for when the height is equal to 0. So this time I have the output. The output is 0, and this is the formula that I'm going to use. For this, what I want to do, I want to try to factor the right-hand side. I always want to try to factor first because this is the easiest method to use to solve quadratic equations. And I know that these two terms have a greatest common factor in common. They have -16 t in common. So I have -16 t times t gives me -16 t squared. And if I do -16 times -3, I get 48t. So I can factor this to be negative 16t times t minus 3, which means that either negative 16t is equal to 0 or t minus 3 is equal to 0. I'm going to divide both sides by a negative 16 here to see that t is equal to 0, or here I'm going to add 3 on both sides, and I'm going to see that t is equal to 3. Only one of these makes sense, and that is when t is 3, because it doesn't make sense that it would hit the ground before I even threw it. So I'm going to cross out t is equal to 0. The answer and only answer is 3, which means it takes 3 seconds for the ball to hit the ground.